In this video we will cover some things that we wouldn't consider vital to our programming, but they really improve our overall experience. And also the experience of the people coding with us or those that have to read our code. And that brings us to docstrings. Docstrings are a way of describing what our functions are doing. And similar to the PEP8 naming conventions, this can be useful for our own coding, but will become really important when reading other people's code or when working on a project together. The docstring is really just a string that we put in the second line of our function, so right below its name and its arguments. We can use double quotes instead of triple quotes, but for bigger docstrings that also contain line breaks, we need the triple quotes. After defining a function with a docstring, we can access the docstring with the doc attribute. We can also put a question mark in front of the function, or use the help function, or shift plus tab, which also gives us the docstring. Usually for more complex functions, we also want to describe its arguments. And for that we can make use of the extensive docstrings. In this course we will use the Google style since it's very readable. And so in these extensive docstrings we have, in addition to the function description, also args and returns. In args we list the function's arguments and briefly describe what they are used for. And returns, as expected, tells us what the function returns. Next up are type hints. Type hints we include next to the function's parameters. And as the name says, they hint at what type a parameter should be. So time should be a string, person should be a string, and it also tells us that the function should return a string. This feature is completely optional, and it will not even throw us an error or warning when we try running the code with different types, as we see here, but it is really useful when we share code with other people or when we have to read the code of other people. And also it's useful when we have to read our code, which is somewhat old. Even though Python does not make use of these type hints, there are some external tools that do use them to spot potential bugs. Now on to args and quarks. While it sounds like quantum physics, we're not trying to catch any particles, but instead loose arguments. So the args with the splat operator in front will catch any loose positional arguments, and the splat quarks will catch any loose keyword arguments. So to see this in action, we have this function here that requires one normal, positional, or keyword argument, and after that we're free to add anything we like. So any amount of positional arguments or keyword arguments. And the function will then print the normal argument, then it will go through the positional arguments and also print them, and then finally it will iterate through the keyword arguments and also print them. Here we can already see the difference between args and quarks. So while args is just a list of all the loose positional arguments, quarks has to be a dictionary, because we don't just have arguments but also keywords. And so arguments are values and keywords are keys. And if we run that function, then test is our normal argument, 1, 2, 3 are our positional arguments, and these here are our keyword arguments. So the word 1 is our first keyword, then the value 1 is our argument, and so on. The args and quarks can be really useful for inheritance, because we can grab the parameters that we need for a child class and call the parent class with the original parameters. Next up, call by value or call by reference. If you're not coming from any other programming language, you might be confused by this question. And so what it's asking is, when we call a function, do we pass a copy of an object or a reference of the object? And if we pass a reference, then changing the object inside the function will also affect the actual object. And for Python, the answer is neither. Because in Python, everything's an object, we could argue that we pass object references. But maybe it's best to ignore all that and just think about how it should work based on what we already know. So when we pass an object to a function, we simply give it another name. So here our integer 1 is passed to the function add1, and in there awaits a second name b that we attach to our integer 1. And with that in mind, we can employ our knowledge about mutable and immutable objects. So since integers are immutable, this operation here will not change our integer, but instead create a new object, to which we bind the name b. So b now refers to this new object, and the original value a is not affected in any way, which we can also see here. So we print it before and after the function, and both times it's 1. Now let's consider a mutable object. So a is a list. When we pass the list to our function, it will be bound to its new name, and because it's now mutable and we have access to it via b, we can in this case append an integer to it, and this will change the object, which also a is bound to. And so printing a gives us a different result when you compare before and after the function. So here it's an empty list, and then the list contains 1. This brings us to an important caveat with default arguments. When we use objects as default arguments, it will only create them once. And while this is irrelevant for immutable objects, things can get quickly out of hand for mutable objects. So here we have an empty list as a default argument, and every time we call this function, the same list will be used. And so the list gets longer and longer and longer. To get around this problem, we can initialize the default argument first with none, and then inside the function with the object that we actually want. So we check if a is none, and then we initialize our actual object. And that fixes our issue. Finally, we have the zip function. And the zip function provides us with two functionalities. In the first use case, we have two lists. So here we have fruits and colors. And we notice that they are connected. So the banana is yellow, the orange is orange, the blueberry is blue. And to connect these values, we can zip these lists. And before we inspect this loop, we can have a look at the zipped list. And we see that it combines the elements at the same position tuple-wise. So banana and yellow are combined in a tuple, and that's the first element of our new list. And then orange and orange are combined, then blueberry and blue. And in our for loop here, we then make use of tuple unpacking. So from this zipped list, we take the fruit, we take the color, and then we print both. And so it prints banana is yellow, orange is orange, blueberry is blue. This also works the other way around. So given that we have a list of tuples, maybe coordinates x and y, we can use this syntax to unpack them, zip them, and unpack them again. And that separates the x and the y's. So if we have a function that needs x and y separated, we can make use of this syntax. Okay, quick summary. Make use of docstrings so that people can understand your code, or more precise, your functions. Use type hints to not forget what kind of type your parameters and return value has to be. If you want to pass unlimited amounts of positional or keyword arguments, use args and quarks. Whether a function will change your object or not depends on whether it's mutable or immutable. Instead of using default arguments that are mutable, initialize them with none. If you want to zip lists, use zip.